we've been able to determine using radiocarbon dating of tooth enamel that Naya died between 12,000 and 13,000 years ago.
For a long time, scientists have wrestled with one enormous question. How did humans first make it to the Americas? A continent separated from the rest of the world by vast oceans and frozen wilderness. Over the years, many ideas have surfaced. Some researchers believe early humans crossed a land bridge from Asia during the Ice Age. Others argue they traveled by sea, following coastlines that no longer exist, now swallowed by rising oceans. For decades, these theories remained just that, theories, until something changed. Recently, scientists began exploring deep underwater caves off the coast of Mexico. And inside those dark, flooded chambers, they started uncovering clues that may finally rewrite the story of human migration. What they found deep below the surface is forcing researchers to rethink everything they thought they knew. So, what exactly did they discover? Let's dive in. The underground world. Along Mexico's Caribbean coast, where turquoise water meets thick jungle, sits the ancient town of Tulum. More than 800 years ago, it was a thriving Maya port city, a place of trade, ritual, and daily life. Today, most visitors come for the beaches, the ruins, and the adventure. Very few realize there's another world hidden beneath their feet. Under this tropical paradise lies a vast underground landscape, frozen in time. If the sea were drained away and the jungle peeled back, you'd find an enormous maze of limestone tunnels stretching beneath the land. These flooded caves, known as cenotes, connect to underground rivers that flow silently through the Yucatan Peninsula. To cave divers, they're breathtaking and dangerous. To archaeologists, they're priceless. Inside these caves, researchers have uncovered bones of Ice Age animals, stone tools, traces of ancient fires, and even human skeletons. Each discovery feels like opening a sealed time capsule. But how did all of this end up underwater? During the Ice Age, sea levels were more than 100 meters lower than they are today. These caves were dry. People walked through them. Animals hunted and lived nearby. It was a landscape full of life. Then the climate warmed. Glaciers melted. Sea levels rose. Slowly, the caves flooded, sealing everything inside, untouched, undisturbed, and perfectly preserved for thousands of years. The environment did the rest. Deep underground, sunlight never reaches these tunnels. The water is so still it reflects the cave ceiling like a mirror, making it almost impossible to tell which way is up. One wrong move, and even experienced divers can lose their sense of direction. Over time, these caves became natural vaults. Inside them, archaeologists found skeletons, charcoal from ancient fires, and even handprints pressed into soft clay long ago. In most places, such remains would have crumbled to dust. Here, they survived. But there was one major problem. DNA rarely survives in these caves. Warm, salty water destroys genetic material long before scientists can recover it. For years, researchers could study bones, but not ancestry. Dating the remains was another challenge. Normally, scientists rely on collagen in bones for radiocarbon dating. But here, the collagen was gone, so they used a different method. Over thousands of years, a thin layer of calcite formed on the bones, sealing them off from the environment. By measuring uranium and thorium inside that layer, scientists could determine how long it had been growing and calculate the age of the remains. When they applied this method, the results were staggering. Some bones were nearly 10,000 years old. Others were even older. These caves had been guarding secrets from a time when giant animals roamed the land, and humans were just beginning to explore the Americas. But who were these people? Chiquihuite Cave high in the mountains of Zacatecas lies Chiquihuite Cave. When archaeologists excavated the site, they expected evidence from about 12,000 years ago. Instead, they found stone tools buried in layers dated to 26,000, even 30,000 years ago. If true, it meant humans were in Mexico during the height of the Ice Age. The discovery sparked intense debate. Some scientists argued the stones were natural. Others pointed to consistent soil layers and ancient animal DNA as proof of human presence. The argument continues today. But the cave forced scientists to confront a possibility once considered impossible. Humans may have reached the Americas far earlier, using routes we still don't understand. The shocking twist. As scientists analyzed ancient DNA from caves across Mexico, the results became even stranger. Alongside genetic markers from Beringia, they found fragments linked to Southeast Asia and Oceania, lineages that no longer exist today. Some DNA appeared to be over 30,000 years old. At first, researchers suspected contamination, but test after test confirmed the same patterns. The implication was staggering. Humans may have reached the Americas in multiple waves, from different directions, long before recorded history. Entire populations may have lived and vanished, leaving behind only faint genetic traces. Nay Aya, the girl in the pit. In 2007, divers exploring a deep chamber called Hoyo Negro, the black hole, descended nearly 100 feet below the surface. There, they found a skull lying among the bones of extinct Ice Age animals. The skeleton belonged to a teenage girl. Scientists named her Naya. She was about 15 or 16 years old when she died, likely falling into the pit when it was still dry, perhaps while searching for water. The fall killed her instantly. When the sea rose, her body was sealed inside the cave for over 12,000 years. Naya's skeleton was one of the most complete ever found from this period in the Americas. Her skull looked Paleo-American, narrow, unlike modern indigenous populations. Some scientists believed this meant early Americans came from a different ancestral group. But this time, something extraordinary happened. DNA survived. Fragments of mitochondrial DNA were preserved inside one of Naya's teeth. When scientists analyzed it, they were stunned. Her DNA belonged to haplogroup D1, a lineage traced back to Beringia, the ancient land bridge between Siberia and Alaska. It's the same maternal line found among many indigenous peoples today. Naya proved that differences in skull shape didn't mean different origins. She was the missing link. But just when the picture seemed clearer, another discovery shook everything again. From Naya to Chan Hole 3, every discovery adds another piece to a puzzle far more complex than we ever imagined. The story of the first Americans isn't finished. It's still being written, deep beneath Mexico's limestone caves. What do you think? Who were the first Americans, and how did they get here? Let us know in the comments. If you enjoyed this video, give it a thumbs up and subscribe for more stories like this. Until next time, see you. DNA survived. Fragments of mitochondrial DNA were preserved inside one of Naya's teeth. When scientists analyzed it, they were stunned. Her DNA belonged to haplogroup D1, a lineage traced back to Beringia, the ancient land bridge between Siberia and Alaska. It's the same maternal line found among many indigenous peoples today. Naya proved that differences in skull shape didn't mean different origins. She was the missing link. But just when the picture seemed clearer, another discovery shook everything again.